Hello, everybody. I'm Everton de Oliveira from the Groundwater project, and I'm very glad to bring you another nice book, Electrical Imaging of Groundwater, or something like that, I guess. If you may correct me if you want. But it is a very nice book. I have the authors here to talk to you, to talk a little bit about the book, introduce themselves so you see that they're real persons. And I just had Kirk remembering me that today, we don't even know, even when you have the image, if it is a real person. It may not be, right? And today we don't believe even in the image of people. But I can assure you they're all real people and nice people. You'll see. I have here Camille Singa. She's a professor at Colorado School of Mines in United States. I have Timothy Johnson. He works in the Pacific Northwest National Laboratory. I have Frederick Day Lewis. He's chief geophysicist and laboratory fellow at the Pacific Northwest National Laboratory. And Lee Slater, he's a geophysicist at Rutgers University in Newark. Welcome, everybody. Thank you for participating in our groundwater project. Could you please introduce yourself? And I'll point at you. Camille first.
Sure. My name is Camille Singa. I'm a professor of hydrogeology at the Colorado School of Mines in the Hydrologic Science and Engineering program in the Department of Geology and Geological Engineering.
Thank you very much. Now, Tim, that's you.
Hello, my name is Tim Johnson. I'm a computational geophysicist and a staff scientist at the Pacific Northwest National Laboratory, which is located in Richland, Washington of the United States.
Thank you. Fred, please.
I also am at Pacific Northwest National Laboratory with Tim in the United States. My role, as you said, Everton, is Chief Geophysicist and Laboratory Fellow.
Thank you. Lee, please.
Sure. Lee Slater, Rutgers University, Newark in New Jersey, just near New York City. And I'm a near-surface geophysicist, primarily by background.
That's very good. I can see from your accent that you're originally from Newark, right?
Yes, I am. No, I'm originally from the south coast of England.
All right. Sorry for the joke. Yeah, okay. So who came up with the idea of teaming up the four of you to produce this book? Actually, a very nice book. Congratulations. And how was the teamwork to get it done? Did you have a natural boss or what? Please.
I think it's my fault that this happened, but it was a process that happened because many of us have worked together for a really long time. And in fact, I think it was maybe 15 years ago, I think Fred and I got asked by the Environmental Protection Agency to help put together a white paper that helped describe how to collect and analyze electrical measurements. And since that time, Lee and Tim and I have also worked on material of this sort. And we just realized that there was a need for an introductory text that would help people that study primarily hydrogeology get into these methods, because I do think there's a bit of a gap between geophysicists and hydrogeologists. And so this book was an attempt to sort of explain at least one geophysical method in a way that's hopefully accessible to hydrogeologists.
A little bit of a gap. That was very nice of you to put that way, right? It's a little bit of a gap.
Yeah, it depends. I guess for all of us, we sort of straddle that gap. So for us, it feels like a little bit of a gap, but you're right. When you're farther away, it can be a pretty big gap.
So you guys, how was working with Camille as a boss then?
Wow, you're really putting me on the spot. Well, actually, I've worked with Kamini for a long time, since we were students. And so it was a pleasure as always. And we did need a ringleader to keep us moving forward, like with any team project that's required. And Kamini stepped up and did that for us. And I'll just add to what Kamini said before. It's just a pleasure to be contributing to this. My introduction to electrical geophysics was actually in the classic text by Fries and Cherry on groundwater, and just a short section on geophysical methods. I think that was the first time I read about geophysics, and especially for these problems. So it's exciting to me to be contributing to something that continues that legacy.
Good. Tim.
Okay. Yeah, Kamini's fantastic to work for. I mean, she kept us on task and going, and was also very patient when it took us a long time to get our stuff in. So, but she definitely deserves the credit for getting the document done and the organization and keeping us going. So, and it was a pleasure to be a part of.
I'm now feeling incredibly uncomfortable because none of this would have happened without the team effort that was this thing. And so it was definitely, and it was during COVID, right? So for all of us, I think it was just hard to get things in on time. So it was just a tough time to put this thing together. And plus Lee was writing another textbook at the same time. He was double textbooking it. So it was probably a busy time for Lee.
Hey Lee, come on, jump in.
Well, that sounds like a chance for me to advertise my. No, I won't do that. I'll answer the question. Yeah, I wouldn't. I guess I'd start by saying Carmony kept us. Really did a great job of keeping us all on track. We were kind of disappearing up down different tunnels a lot of the time. I think trying to get away from this book to do other things, and she managed to keep us on task and prioritize this and get this thing finished. So thanks Carmony for doing that. And I also can say that for me, being part of this book I was glad to be asked to be part of it, because I'd seen John Cherry's presentation on why he thought this book was important when I was up at the University of Waterloo in Canada, and he gave a presentation as part of a meeting I was at, and I learned about the concept of the book. So I don't know how long it was after that, but maybe 6 months afterwards, Carmony asked me to be involved. So it was good. It was good for me to get a chance to contribute to this.
Thank you. Thank you. I think it's going to be good for the readers as well. So electrical imaging for groundwater. What is it? And why do you believe this is important? Who is your anticipated audience or readers? Go, let me see, Tim.
Oh, I knew you were going to ask me, because I'm probably the least apt to answer this question, because Lee and Carmony are both in the academic arena, which they're much better suited to answer this question than I am. But well, I guess I would say from my perspective, this topic is important and useful because of the difficulty of collecting data that informs us about what groundwater systems are doing through direct sampling. I mean, we have well bores, we know there's heterogeneity, and because of that, we just can't collect enough data through well bores to adequately understand. And electrical properties of the subsurface are sensitive to things that are very important in groundwater. And so we can use these methods to remotely image or remotely sense what's happening in the subsurface, and therefore begin to solve this data paucity problem that we have in hydrogeology.
Good, good. I'll jump to Camille, because I read here on your resume some very interesting stuff. Like you have worked with mapping, let me see, there's one that attract me. Imaging tree water.
Oh,
That's
yeah.
very interesting.
Yeah.
And you have also, let me see what, imaging water moisture dynamics in desert ecosystems, exploring changes in infiltration after fire. Wow. Okay, now you can come back and tell us about the groundwater imaging here, please.
Yeah, I mean, I think that for so many of us, these methods, they can be hard for students to get into. And so for me personally, I was interested in being able to write something that was accessible to undergraduates who might have some experience in hydrogeology, but maybe none in geophysics. We're the first, I think, of the multiple hydrogeophysics texts that are coming out. And in some ways, I think we have the easiest method to explain to hydrogeologists, because electrical imaging, Ohm's law looks exactly like Darcy's law. And so the groundwater flow equation looks exactly like the electrical flow equation. And so in some ways, because they're so similar, we can use a lot of descriptions that are familiar to a hydrogeology audience. And so that was definitely our audience. And I mean, to your point of these things you're talking about, there's all kinds of cool things that we can do with geophysics that might allow us to understand parts of these subsurface or hard to access systems, as Tim was talking about, that we wouldn't otherwise have access to. And I think this is a group of people that have all done some really unusual, interesting things with geophysics. I mean, Tim has probably collected some of the world's most interesting and large 4D data sets, looking at big changes in time and space. Fred recently has been working on all this pore scale stuff that, why do we measure at the big scale that we think is happening at the really small scale? And then, Lee has been a fundamental person in sort of the world of biogeophysics, which is super cool, using geophysics to understand biologic processes, and also has collected some data sets that he in fact, in the book, we talk about one of the data sets that he collected out at Hanford that I still think is one of the coolest data sets that combines electrical resistivity and induced polarization in rivers, so that we can understand where uranium is being contributed into the river at a large scale. So I mean, I do think that's, this has been a really fun team to work with, just because they've worked on so many disparate problems for such a long time.
Yeah, it's very good. It's very good. So what is the overall structure of the book, Fred?
Well, we cover the soup to nuts of electrical resistivity imaging, starting with survey design and data processing, and then inversion, and understanding the information content of the images that we generate, which is critical to translating geophysical results into information to help develop or calibrate groundwater models. So that's a step that's often, I think, overlooked in the handoff between geophysicists and hydrologists. And so we tried to pay attention to that and include some exercises around that.
Very good. Your section 2, goes straight to designing surveys. That's quite interesting, because you go from introduction to the design. Usually the design comes after you dump all the information into the reader. That was quite nice. What is the advantage of this presentation in your view, right? And please introduce us to the SEER, Scenario Evaluator for Electric Resistivity, please.
That's definitely Fred's right there. Fred was the one who was the brainchild behind SEER. So
okay, thanks. The advantage of launching straight into survey design is that this is critical to getting good data and data that provides information. And again, it's something that's not always tended to well in textbooks on geophysical methods. So we tried to get in some best practices, some guidelines, rules of thumb, and then also provide the user with pointers to tools like SEER. The Scenario Evaluator for Electrical Resistivity allows the user to, for a hypothetical model, predict what they might see in the subsurface. So it gives the user an idea of the ability to see with X-ray vision into the subsurface, but that X-ray vision isn't perfect. It's not 20/20. It's kind of blurry. Like if I took off my glasses, and understanding that glasses prescription is really important.
Yeah, well, I really enjoyed the way it was presented. Congratulations, guys. It was very, very nice. I've been reading. I'm a geologist, and I use geophysics now and then, right? And that was quite interesting because you go first and you see the idea of what you're doing, and then you jump into the details. That was very nice. So about the necessary, let's say, what is necessary to collect and verify data properly, and how do you approach that in the field? Who's going to grab that? Tim?
I think Lee, because the next question I think is perfect for Tim. So I think Lee would be awesome at answering how to collect good data as someone who has collected a lot of good data. So.
Yeah, that is covered quite extensively in the book, and this is something that when I was a PhD student, which was a very, very long time ago, as Camille would tell me, that I was luckily advised by somebody, Andrew Binley from Lancaster University, who came into geophysics from a hydrogeology perspective, and he was so focused on measurement errors because he understood that collecting good data and understanding the data and actually quantifying the data, actually applying some uncertainty to the measurements that we collect, was critical to actually doing electrical imaging well. And there was a whole community of geophysicists not doing electrical imaging well because they were not aware of the significance of errors and bad measurements on the inversion of these data sets, which is what gives you these images that Fred was talking about in relation to SEER. So the book actually spends quite a bit of time on this, and we lay out not just how to collect good data in terms of signal to noise, but also once we have the data and we're going to invert those data to generate the images of the subsurface, how do we actually quantify those data correctly? How do we use those errors that we can quantify in the field to get the meaningful images of the subsurface that are not affected by what we call artifacts of the inversion?
Oh, you mentioned the data inversion, right? Which is also greatly covered in the book. How is it presented in the book? And what about the exercise on that? Who's gonna take that? Lee again?
I think we should give this one to Tim as the one of us that has actually written a very well used and popular inversion code. So Tim has written a code that's been used by, I don't even know, what was it, 10,000 unique users or something, Tim? There's a lot of people that use this code.
I would guess that, you know, when we talk about these methods, that inversion is the most foreign part to people and the hardest to understand and grasp. And so, but it's, you know, it's also one of the pillars, one of the most important ones to understand what's happening in order to appropriately use and analyze your data. You really need to understand what the inversion is doing.
Oh, Tim, so tell people what inversion for those who don't know and will read the book.
So the inversion is the process of using the measurements that we collect to estimate the electrical properties that are causing those measurements, basically. So we don't measure them directly, and so you have to. And the word inversion comes from the mathematical matrix inversion. There's a big matrix inversion involved in the process. So it's just the process of estimating that. And these are all done on a computational mesh, and the problems are non-unique. And so we have to regularize them, we call it. We have to introduce other information to get useful images. And that whole process is just complicated, and it's computationally demanding, or it can be. And so I think in the book, we try to lay that out with enough detail that people can understand what's happening, but not so much detail that they get buried, you know, in the weeds, basically. So, and as far as the exercises go, I think that our other three authors did the exercises. So I'll let them comment on those. I don't think I did any of the exercises, Camille. I think,
is that right? I don't actually remember what
yeah.
we did.
I did some of the examples, but you guys did the exercises. You professors.
Remember the exercises. I have blocked them out. I don't remember what we did for inversion exercises at the end.
Well, but you also have you have the software, the spreadsheet, right, Fred? That's available on the book for people to use. Tell a little bit about that.
Yeah, and we talked about that briefly before. That's the scenario evaluator for electrical resistivity. This doesn't support inversion of real data, but what it does is it gives the user the ability to predict what image would result from some hypothetical model in the subsurface. So if you have a hypothetical target, an underground storage tank, or a pool of contamination, you can predict what it might look like in a resistivity image. And you can do that for different survey designs, error levels, and assumptions to see if it's worthwhile even going out to the field and collecting data, if you have any hope of resolving the target that you're setting out to resolve.
Yeah, and I mean, there is a lot of freeware software out there for inversion, which we mentioned in the book. So Tim obviously has a really nice code called E4D that he's put together that's got a ton of users. A bunch of our German colleagues have put together a Python-based code called PyGimli. Lee's former advisor, who he mentioned, Andy Binley, has put out some codes on his website that are available. R2 is one of them that someone recently has written a Python-based GUI for. So there's actually a lot of codes out there, but the big concern for us was the sort of garbage in, garbage out factor, both to Lee and Tim's comments that, if you don't exactly know what's happening in this inversion process, and there are lots of codes out there where you can sort of dump data in and get a picture out. And I think that's caused a lot of harm to the use of geophysics and hydrogeology through the years, because there's pictures of stuff and people want to think that those pictures are the truth. And in the end, they're flawed by lots and lots of things in that process. So.
Yeah, that's a very important point. It's a very important point, because you're getting bad data, right, and not interpreting it well. It's very common. It's very common. I know that because sometimes you get some results from geophysics and you see that the data was not correctly, gathered and not interpreted well, and probably the inversion was wrong as well. Everything goes badly. In your book, you have some very nice illustrations about that. Who produced them?
A lot of the really pretty pictures are Tim's, I think.
It was a team effort. I mean, we all worked on the figures, so.
They're very good. They're very good. Congratulations, guys. Okay, guys. I know your time is short today, and we can talk a lot about this book. But I'll ask you to make your final statements, and I would like to congratulations you all for the very nice work that you put together. It's very good. We'll ask people to translate. I'm responsible for the translations, and I'm pretty sure we'll have for a Portuguese translation. I'll make sure the Brazilians work hard to get this book in place in Portuguese soon enough. All right. So please make your final statement.
Oh, I guess I wasn't ready to make a platform statement here, but I guess I will say that this has been an interesting experience, both the book and the interview. I have really enjoyed working with these guys, and I do think the book has a lot of value. I've been involved in writing a number of different things recently, including, as Camille mentioned, another book, but I like the ebook concept. I like the fact that it's going to be so freely available and so widely distributed, and it will get to perhaps people that books like the other book I was involved in will never get to. So it's been a pleasure to be involved in this, and Camille, thanks for dragging me in and putting up with me, and I will pass the platform.
Okay, Tim, please. Thank you, Lee.
Well, I'll second what Lee said. I didn't know about this project until Camille introduced it, and then I started seeing some of the other books that were coming out and things. And I think, in today's world where everything's available online, it's just a fantastic idea to make these books and topics accessible to everyone. And so it was a nice thing to be a part of, and I appreciate the opportunity. So.
Thank you very much. Thank you. Fred, please.
Well, I'll just echo everything that Lee and Tim said. It was a pleasure to be part of this, an honor. I'm glad to have contributed to this resource, to the hydrologic community. And I think there's a lot of potential for using electrical methods for characterization and monitoring in hydrogeology. So I hope to see a lot come from the people who read this book and use it for teaching.
Thank you. Camille.
Yeah, I guess I'm closing it out. Well, I just wanted to say thanks to Fred, Lee, and Tim. I always learn a lot from working with them, and they're three of the best geophysicists out there. So I'm really glad I got to work with them on this book. I am also glad to be part of an ebook process. Having used a bunch of the other textbooks in my hydrogeology class, it has been a game changer to have free texts available to my students. I was using a book that for groundwater that had last been updated in like 2004, and it's hard to tell people that something is important to their lives when they were born right around that time, and there hasn't been a book updated since that point. So I'm super glad to be part of this. I do hope that this book and the other geophysics books that come out will be sufficient to help someone run a hydrogeophysics class in their institutions. And I look forward to the last couple, whoever is writing Solute Transport out there, I need you to finish that book. I need it for my class. But yeah, I look forward to the rest of these ones getting published. So thanks for letting us be a part of it.
Yeah, well, thank you. Thank you very much, the four of you, for the nice book that you put together. It was a pleasure meeting you guys. I'm sorry that I have to rush here, but you had a short time to finish up, so that's why. I would add some more questions to you, but people will be happy to find the answers in your book. Thank you very much, and congratulations for a nice work.
Thank you.
Yeah.
Thank you.